Sun brings us light and heat, thereby thriving life on the earth. When human beings enjoy energy from sun, they also learn and think how to utilize light and heat emitting principle of sun, nuclear fusion, thereby meeting the demands of human energy development. Hydrogen isotope deuterium and tritium are mixed and heated to high temperature of millions of degrees, thereby making nuclear aggregate and produce huge energy. This is nuclear fusion. Human beings had realized nuclear fusion reaction in the early 1960s, which was hydrogen bomb. However, huge energy released by nuclear fusion cannot be controlled at the instant of hydrogen bomb explosion with extremely strong destructive force. Only when the nuclear fusion reaction is controlled, energy can be slowly released. Is controlled nuclear fusion. Therefore, such energy can be utilized as energy for social production and human life. Controlled nuclear fusion reaction process does not pollute the environment or produce high radioactive waste. In addition, seawater is rich in abundant raw materials of nuclear fusion, deuterium and lithium. Therefore, implementation and application of controlled nuclear fusion will provide human beings with inexhaustible clean energy. International Thermonuclear Fusion Reactor Experiment Plan is referred to as ITER Project. It has opened the international cooperation history of controlled nuclear fusion energy utilization. Human beings have achieved the global coordinates on the developing road of obtaining new energy. ITER Project, as an international mega science cooperative plan, has jointly cooperated by 7 parties, namely China, European Union, India, Japan, South Korea, Russia, and the United States. 35 countries in the 7 parties cover the world's major nuclear powers, with more than half of the world's population, since the controlled nuclear fusion energy principle studied by the plan is the same as light and heat emission from the sun. Therefore, it is also known as man-made sun. Successful implementation of ITER project will make a contribution to solving the common energy problem, environmental problems, and social sustainable development problem faced by human beings. Entering the 21st century, China has become a great power of energy consumption all over the world. Storage of energy resources is uneven with high development difficulty. Serious shortage of high-quality energy is approved, such as oil, natural gas, etc. The threat of energy depletion may come earlier and more seriously. The development of new energy has become an urgent demand for dealing with energy crisis. Chinese government formally took part in ITER project negotiation in January 2003 and successfully undertook the 9th and 11th Intergovernmental Negotiation Conferences of ITER project in 2003 and 2005. In 2006, ITER Joint Implementation Agreement was signed in Élysée Palace, France. Subsequently, the agreement was approved at the 29th meeting of China's National People's Congress (NPC) Standing Committee on August 30th of 2007. China submitted the agreement approval document, signed by then President, to International Atomic Energy Agency (IAEA) in September, which marked that China officially joined ITER project. China has the chance to take its place in major international cooperation plan leadership by joining ITER project negotiation, thus opening the door for Chinese scientists and engineers to equally enter into international leading large scientific project field. ITER project aims to demonstrate the scientific and technological feasibility of fusion energy for peaceful purposes with duration of 35 years, including the construction, operation, and exploitation phases of 30 years. Finally, it will be delivered to the host, France, for device deactivation and decommissioning. Through participating in ITER construction and operation, the development process of thermonuclear fusion energy in China can be accelerated, thereby driving technology development of China in nuclear science and technology, superconducting technology, high-power microwave technology, plasma application technology, high-energy particle beam technology, complex system control technology, precision processing technology, and related fields.
我们要通过这种重大国际合作计划的实施，把我们国内的各个方面的资源整合起来，要消化ITER的研究成果，为我们所用。
Nuclear fusion research in China was started in the early 1960s, and the related talent training and research work has lasted for nearly 50 years. China has the main objective of realizing controlled thermonuclear fusion energy from the very beginning with a stable development to establish the nuclear industry, Southwest Physics Research Institute, and Plasma Physics Institute in China Academy of Sciences successively. A large amount of research and a series of physics experiments were implemented in the aspects of high-temperature plasma physics, research and development of magnetic confinement nuclear fusion engineering technology, and related high-technology, plasma constraint, balance, thermal experiment, and theoretical research, high-voltage large current, ultra-high vacuum, strong magnetic field, etc., obtaining a lot of research achievements. China's research on magnetic confinement fusion plasma physics has rapidly developed along with China's accession to ITER project. University of Science and Technology of China, Huazhong University of Science and Technology, Dalian University of Technology, as well as other colleges and universities have established nuclear fusion and plasma physics majors or labs. Tsinghua University, Peking University, Beijing University of Science and Technology, other colleges and universities, and Chinese Academy of Engineering Physics, China Institute of Atomic Energy, and other scientific research institutes have carried out related research in the field of nuclear fusion. A large number of research talents in the field of nuclear fusion are cultivated. In April of 2011, President Xi Jinping inspected the Institute of Plasma Physics Chinese Academy of Sciences and comprehended ITER device and EAST configuration similar devices. Then, he affectionately said that human survival is always inseparable from energy. Sustainable utilization of energy is inseparable from the progress of science and technology. Such research opens a bright way for people to select energy in the future. In October of 2008, China International Nuclear Fusion Energy Plan Execution Center was established in order to better fulfill China's commitment to join ITER project and project various rights of China as a fair partner in ITER project. The center actively participated in ITER organization management as China Domestic Institutions, CNDA. It is responsible for containing and coordinating various activities of ITER organization. A lot of ITER project management and technology documents are formulated and converted. The domestic research institutions have been actively organized for participating in the overall design of the audit, updating and component detailed design of ITER device. The designing, technology certification, production, testing, assembly, and other work of procurement tasks of ITER device parts in China have been organized and implemented. Personnel have been actively selected or recommended for participating in work at ITER organization management level and technical level. Up to now, Chinese personnel accounts for more than 8% of the total employees in ITER organization, which is just lower than the host party European Union. Chinese personnel are distributed throughout all bureaus, Office of Director General, as well as Office of International Cooperation and Coordination of ITER Organization. ITER China team has been insisting on making efforts of national industry and research fields, thereby steadily promoting the core of domestic implementation work of ITER project. The assumed manufacturing tasks, such as superconducting conductor, are highly recognized by ITER organization in the aspects of project progress, performance indicator, and others. ITER China team has introduced domestic independent research and development achievements to ITER project design concept. Its industry feasibility can be optimized and improved, thereby making important contributions to the design perfection and a key engineering technology validation for many systems such as magnet feeder, magnet support, plating, power supply, and other systems. The first part of Chinese party delivered to ITER site certified copper-based conductor for Poloidal field PF number 5 coil was smoothly delivered to the destination on June the 3rd of 2014. The conductor is the first large part which is successfully transported to ITER site among all member parties since ITER project was implemented. It plays an important promoting role for smoothing the implementation of ITER project. The total power of ITER device fusion can be up to 500,000 kilowatts, which is an experimental reactor with plant scale. Currently, it is generally believed in international nuclear fusion field that scientific and engineering technology foundation has been achieved for constructing and operating ITER. It is anticipated that fusion energy commercialization can be realized in the mid-21st century through demonstration reactor, fusion energy demonstration power plant, commercial reactor, and 2 stages of commercial fusion nuclear power plants. Participation in ITER project is a major decision made by China for the sustainable development of energy in the future. Through participating in ITER design and construction, China is able to have the equal access to licensed use. Besides, undertaking procurement package tasks in ITER project is beneficial for cultivating excellent talents of fusion field, improving fusion research and development strength, and laying a solid foundation for realizing fusion energy commercialization in China as soon as possible. In the future, under the high attention of Chinese government and national strategic guidance, the scientific and technological community and industrial community should make joint efforts with other parties of ITER to make contributions for the early realization of fusion energy utilization.